Okay, so first I'll just give a brief overview of what's included with the installation package. So here we see the Emotiv standard libraries folder that gets installed with the SDK. This is obviously on a Windows operating system, so it's located in program files, then this folder called Emotiv standard libraries. So this folder includes code examples, the EDK libraries, some documentation for how to get started with different code examples, and user manual for the SDK, as well as some developer support applications and scripts that go along with one of those applications. So first, I guess we're just going to get started looking at some of these code examples. So we have code examples for both the Epoch and the Insight headsets. So let's take a look at these examples. So we have in this normal examples folder is the C++ examples. .NET has some C# examples, and then we also have Java, MATLAB, and Python examples. So let's just take a look at one of the normal C++ examples to start. So all of the C++ examples on Windows are Visual Studio projects. You can get a free version of Visual Studio Express online from Microsoft's website. Okay, so here we've opened up the main solution, which has all of the code examples included. First, we're just going to take a look at one of the basic examples, which is the emo state logger. So this is a good starting point if you're unfamiliar with the SDK and how to retrieve information from the headset. So this is basically the main file for this code example. And this example actually does expect a command line argument for the log file name that we're going to be logging all of the data to. So I've already done this, but if you just, before you run this project, go to Properties and go to the Debugging tab. Here in Command Arguments, you can provide the file name that you want to store the log information to. Okay, so let's go ahead and run this and take a look at what's going to happen. Okay, so when the example starts, it'll ask you to enter in an option to either connect to the emo engine, which is basically connecting directly to a headset, or to connect to Emo Composer, which is a developer application that we'll talk about later, which is basically an emulation tool that you can use to simulate all the outputs in software. So let's just go ahead and connect to the headset. All right, so you can see here, none of the information is displayed directly here. It's just logging all of that to the file that we provided through the command line argument. But we'll go ahead and just let this get some data and then look at that file right after this. All right, so now we should have about 25 seconds of data from the headset in that file. So if we go back to the directory where the code examples are, the emo state logger project is actually example 1. And here you can see all the project files as well as the log file that we just created. So if we go ahead and open this up, you can see basically an Excel sheet of all of the detections that were being logged by that sample project. So we have some effective detections and all of the expressive detections. for different facial recognition. And you can see we have about 25 seconds of this data. So this is pretty much a good starting point, this code example, just to show how to retrieve this, this information from the engine. So let's go ahead and take a look at what's going on here. So, you know, when you're starting out creating a new project, you'll kind of want to replicate what's going on here. So obviously we need to include the header files from the Emotiv package, and these header files contain all the function declarations for the APIs. And then the first thing you're going to want to do with each application is use these function calls to create an event object and a state object. And these are used throughout the rest of the API to retrieve information from the engine. Here we have that initial option for connecting to the engine or the composer. So if we're connecting to the engine, we just use this normal engine connect call, and then we check the return value just to make sure that everything's okay. Otherwise, we obviously have an error. And the second option for connecting to the composer application, we use this remote connect function call. And there's a specific port number for that composer application, which is basically an emulation tool. There's also a specific port number that you can use to connect directly to control panel. And there are some benefits to that that we'll talk about later. So basically, once we're connected, we go into this main loop right here, which is basically a polling loop, and this is what you'll use in any application to retrieve information from the engine, whether you want to put this in a separate thread or some type of event handler. This is basically the flow of how you're going to retrieve information. So the first thing we do is get the next event available from the engine, and we check the return value of that. You know, if we successfully retrieve that event, then we go ahead and check the type for that event. There's a few different event types, which you can see here if we go to this event type definition. So there's user added, user removed, basically tells us if a new headset's been attached to the computer. Emo state updated, which tells us there's new information from the headset. There's profile events and other specific events for training, cognitive, and expressive. And basically in our project, we're mainly concerned with emo state updates. So this tells us that there's new information to retrieve from the engine. So if that's the case, we get the state from that event, which is basically a snapshot of all of those values. And from there, we can use this state to retrieve all of that information. So for instance, here we're just getting the uptime of the headset, so how long the headset's been active and connected, just as a timestamp. And then here in this log function is where most of the retrieval is done. So if we go to that, you can see here, you know, we're retrieving the uptime from the state, we're retrieving the wireless signal status from the state, most of the expressive detection values here, and then also some of the effective values. And then we can also get which cognitive action is currently being performed in the power of that action. So that's pretty much all there is to this example. So this is a good starting point for like I said, just getting familiar with how the SDK works. There's also obviously some other examples here for doing cognitive training, uh, getting gyro data, doing profile management, how to handle multiple headset connections. So, everything's basically here to get you going as a good starting point for how to use all this functionality. All right, so now I'm going to move on and talk about some of the code examples in the other provided languages. So here we also have, C#, Java, MATLAB, and Python. So let's just go over a Python example really quickly. Here I have, if we open up a command window really quick, you can see that I have Python 2.7 installed on my machine. I'm fairly sure these will all work with 3.3 as well if you wanted to use the newer version of Python. So I have a 32-bit version of Python installed, so the first thing you'd want to do before running these examples is take a look at one of these folders. So obviously x86 would be for the 32-bit libraries, x64 for the 64-bit libraries. But what you're going to want to do first is just grab a copy of these libraries and just paste them directly into this folder so that they're on the same level as these Python scripts. And then we can go back here and just run one of these examples. So I'm just going to run the emo state logger in Python, and we'll connect to the headset as before. Okay. So you might run into an error with permissions. So we'll just need to make sure that this folder is not read-only. Nope, still. Okay. There we go. Okay, so now it'll create this es.csv file, which will log all of the emo state data to. And once we're done with that, we can just hit any key to exit this. And then we can take a look at that log file. So this looks pretty similar to what we got from the C++ example, just logging all of the effective and expressive data. All right. So now we can take a look at one of the Java examples. So here we have, again, an emo state log example. So this is set up as a Eclipse project. So I'll go ahead and open Eclipse and set up a new workspace and import this project. Actually, I've already done that, but let's start from the beginning just to go over this. All right, so first we're just going to import that project. And then this is also described in the documentation for getting set up with the Java examples, but the first thing you're going to want to do after importing one of these projects into Eclipse is go to your Java build path, and I've already done it here, but this JNA library will most likely be pointing to the wrong location. So what you're going to want to do is just remove the one that's there and go to Add External Jars, and you should be able to find the JNA library here in this lib folder within the Java examples folder. So just go ahead and include that, and it should fix any build errors you're seeing with this project. Okay, so we'll go ahead and give this a run. And you can see here it's just logging all of this emo state information to the console. So, if you wanted to build anything with Java, this is obviously a good starting point for that. I'm going to go ahead and just give a brief overview of the Emo Composer emulator as well right now. So if we change this option to 2, we'll use this remote connect call, which will connect to Emo Composer. So if we go back to our SDK directory within applications, you'll see this Emotiv Xavier Composer application. So let's go ahead and open that, and then we'll run our example here now connecting to Emo Composer. So now within Emo Composer, we can actually manipulate all of these values for the different emo states. And we can go ahead and send just a single state, and you can see that the engine retrieved it with our values that we had in Composer. We can also just continually send emo states to whatever app is connected, let's say every half a second, and using this auto reset checkbox, once we start this, we'll just continually be receiving those emo states in our application, and we can edit these values on the fly. So you can see those values updating in real time in our console. So this is a nice tool just to be able to test your app functionality without actually having to use the headset every time. So this is a nice emulation tool to be able to do that. Okay. One other tool in the applications directory, which may be of use to some of you, may not be of use to some of you, but there is this application called Emotiv Key, and this is basically a tool to map some of the different headset detections to either keystrokes or mouse buttons and things like that. So we'll just go ahead and connect this to Composer just so we can demo this fairly quickly. So first thing you're going to want to do with this application is just add a rule, and this is basically what's going to be triggered when the headset detection is detected that you specify. So I'm just going to have it write maybe LOL every time something happens. So once we have that rule, we can add the condition for that rule. So the default, let's just say, every time a smile occurs, we'll type LOL to whatever's in focus. Okay. So now we're connected to Emo Composer, and we're our sending states, and we can make sure that this value checks out. And now you can see this little bulb changed to a green, meaning that it triggered this action. Probably can't see it typing LOL unless we trigger that again. But yeah, you can see that this changes from green to yellow when it's detecting that trigger condition or when it's not detecting that trigger condition. All right, so that's basically all there is to Emo Key and Emo Composer. We can also simulate, wireless signal, or battery status, and the different contact quality for whatever connected app that you're using, just if you want to make sure that your app is correctly displaying this information. You can use Emo Composer to manipulate all of these detections. So we can even do a custom array and just, change these how we see fit if we wanted to. All right, so that pretty much covers Emo Composer and Emo Key. Just going through a couple of more items in this SDK directory. The EDK folder just has those basic 32-bit and 64-bit libraries. So if you need a place to just copy those from quickly, they're all here in this EDK folder. Here in the documentation folder, we have just basically some quick start guides for how to run these examples, as well as the user manual for both the Epoch and Insight SDK. And then here in these folders for Epoch and Insight, we actually have the API reference documentation if you want to take a look at all of the specific functions and data types that are included with the API. And then these composer scripts can be used with Emo Composer. They're basically pre-written scripts that will perform specific actions in Emo Composer. If you don't want to manually manipulate that data, you can use one of these scripts. Just load them into Emo Composer, and it'll run, like 10 to 20 seconds worth of Emo state data. So that's basically all there is to the SDK. You should have a pretty good understanding of how to get started with developing applications now. I would like to open it up to questions if anybody needed some clarification or had specific questions they'd like to ask about using our SDK. All right. Doesn't look like anybody has any questions. I'll give it another 30 seconds and just see if anybody is having trouble using the GoToMeeting interface or if there really are no questions.
Benjamin? I think one person asked about Linux. Oh, you had a question about Linux support?
Yeah, basically what the state of the Linux support is, or how well it is supported.
I believe we have Linux support for Ubuntu and Fedora, and then obviously we have Mac support as well. So it'll look fairly similar to what you saw for the Windows SDK. The examples are mostly just run from the command line though in Linux.
Okay, thanks. Cool.
All right. Looks like there's no more questions. So thanks everyone for attending. And if you have any other questions, please feel free to reach out to hello@emotiv.com and just send an email with any questions you may have there. Again, thanks for coming out and enjoy the rest of your day or evening.